Section 8.4 is on graphs of quadratic functions. In this section, we'll look at the graphs, we'll look at how to graph them, and the properties of graphs of quadratics. For example 1, we have the function f of x equals x squared plus 2x minus 3. First, we're going to do our xy table. So in this case, it's every time we plug in a value for x, we're going to solve it and get the value for y. So this should be pretty quickly. You guys can plug these in your calculator. Plug in negative 4 for x. We have negative 4 squared plus 2 times negative 4 minus 3 gives us 5. Plug in negative 3 for x. We're at 0. Negative 2, we're at negative 3. Plug in negative 1, that gives us negative 4. 0 gives us negative 3. 1 gives us 0. And 2 gives us 5. So then we're just going to go ahead and plot these different points. So negative 4, up 5, negative 3, up 0, negative 2, down 1, over 0, down 3, over 1, up 0, and over 1, 2, up 5. Okay, and then go ahead and draw your line. You can also graph this using the graphing calculator. Alright, some vocab for quadratic functions. Parabola, you guys have seen this term before. That is just the shape of the graph of a quadratic function. Each parabola has an extreme point. These are going to be our min or our max. And then talking more about the minimum and maximum points, we have a minimum point, so that's going to be the lowest point on your graph. We have that if a, so the first term, is greater than 0, and that makes the parabola opens upward. A maximum point then, we have if a is less than 0, and the parabola opens downward. Another term you'll see for these words, your minimum and maximum, is also a vertex. That's going to be your minimum or max, or your extreme point of your graph. Alright, example 2, we're dealing with two different parabolas here. We're looking at their minimum or their maximum. So if you look at the graph on the left-hand side, you see that it opens downward. This one's going to go with the function y equals negative 2x squared plus 8x minus 6. It opens downward because a is less than 0. So you see that our max at this point, if it opens downward, it has a max. So our max is 2, 2. But now look at the graph on the right. This one is going to go with the function y equals 2x squared minus 8x plus 6. This one opens upward because a is greater than 0, so it opens upward. In this case, we have a minimum, so you see we have that minimum at the point 2, negative 2. Alright, to find the vertex algebraically of a quadratic function, we're just going to use this little equation, x equals negative b over 2a. This gives us the x-coordinate of a vertex, to get the y-coordinate, we plug this value in for x to get your y-coordinate, because we want an xy point as our vertex. Likewise, we can find the y-intercept pretty easily. In this case, we just let x equal 0 and solve for y, which what's going to happen, everything's going to cancel out except for c, so your y-intercept is going to be the point x, comma, c. Alright, for example 3, we're going to find the vertex and the y-intercept of a function. Here we have the function y equals 2x squared minus 8x plus 6. So we have our formula for the vertex, x equals negative b over 2a, which in our case this is going to be negative 8 over 2 times 2, or 8 over 4, which gives us 2. So that means the x-coordinate is 2. Plug that x-coordinate in to find the y. So y equals 2 times 2 squared minus 8 times 2 plus 6, which is, let's see, 2 squared is 4, 4 times 2 is 8, minus 16 plus 6 gives us negative 2. That means our vertex point is 2, comma, negative 2. Now, find the y-intercept. We're going to let x equal 0 and solve for y. So y equals 2, 0 squared minus 8 times 0 plus 6. So the first two terms cancel out because you're just multiplying by 0. So y equals 6, which remember 6 is c. So really for the y-intercept, you don't have to do much math. You just have to say, well, my y-intercept is going to be the point x, 0, y is c. So there's the two kind of key points of this parabola. Now if we continue on with example 3, and let's say we want to graph it using our vertex and our y-intercept. So we know what those 2 points. So we'll go ahead and graph those. Graph the 2 points. So there's my vertex, and then my y-intercept is 0, 6. So we know that our vertex there is our minimum point because it opens, a is greater than 0, so it's going to open upward. So we just kind of sketch, we know it needs to go up like that. Well, it's going to do the same kind of on the other side, because remember they're mirror of each other. So we just kind of sketch it from there. And then you can double check that in your graphing calculator. There's some examples on your homework that have you graph it using the vertex and the y-intercept and then check it on your calculator. I want you to sketch the graphs of those. Using your vertex and your y-intercept, I want you to list those so I know that you actually found the vertex and the y-intercept. And then, just roughly sketch your graph and make sure you're graphing it with your graphing calculator there too.